from London. And my next guest is Ivan Ponomarev. Welcome.
Yeah, thank you.
We know we go way back, and know Ivan from a bunch of community events, Java related, but we also kind of colleagues just to how do you call it, disclosure. Ivan works for a company called Synthesized. I have the pleasure and the honor to be on developer relations advisory. So we're kind of colleagues, which is pretty cool. And basically, Synthesized do what the name implies: synthesize data. What is it? Why do we need it? Why it is important?
Imagine you have a huge database, maybe some legacy database, some legacy system, and so in most cases it's like good old relational database. But the data there might be sensitive, and you might not want to share it with like outsources, developers, so something outside of, so that it won't leak outside of your organization. But developers and testers, they do need data. So what Synthesized does is like provide us with your database schema, maybe provide us with some extra metadata, and we can generate test data for you from scratch in this relational database. Oh, there are some other options. We can mask data, we can generate it from scratch, we can subset it. But so everything that you can do with your production data in order to fully separate it from test data.
This is, I think I remember myself as a developer many years ago getting some access to production database to use for testing, and then seeing all the credit card numbers and what's not. And I'm like, well, this is useful because I can do tests, but it feels wrong because I really should get access to that. But I think there is like it's a trade-off that Synthesize provide a good solution, but without the synthesized data, it's really hard to overcome, because developers do need data which is as close to production data as possible for testing, for example. But also, if you don't want to give them that, you need to give them something instead which is close enough.
Yeah.
So how do we do that? How do we know that the data that we provide the developers is representative of the real-time data that we work with?
Oh, that's actually the core trick of the system. So what we do, so we try to extract as much metadata as we can about the characteristics of the data itself. Of course, what's on surface is database schema. Like if it's varchar, then it's text, and if its length is limited, then we know something. But if we know some example data in the real database, we can draw some conclusions about what we. So if it looks like credit card numbers, then we'll generate realistically looking credit card numbers for you to test.
And it obviously goes for names, last name, first name.
Addresses.
You kind of guess, well, that's a name, so we need to generate whatever names and addresses, of course.
That's a number, and for example, this number has like these statistical characteristics. So we can just randomly generate the number with the same statistical characteristics. A price around 100, for example.
This is very cool. And this is also, I would say, it's like big data and machine learning.
Well, these are fancy words actually, but I would like refrain maybe to put these labels here, as we yes, there's of course some machine learning is involved here, but this is still work with one maybe huge but relational database. So is it where's the like? Is it big data or not? Is question.
Oh yeah. No, but machine learning for sure, right?
Yeah, of course.
If you need to understand that, okay, it's not just the number, and it's not just the price, but it's always between $50 and $150. That's a very machine learning conclusion.
Yeah, exactly, and that's what our software does. Actually, it's able to analyze data, but we can also do it from scratch. If you have no data at all, we can infer something from your database schema, or you can provide us with YAML files, like your estimations of what these fields are going to be, and we can generate it for you from scratch. For example, if you are developing a new application.
Yeah, that makes sense, and probably you can also provide hints that will make it more precise if whatever was inferred is not 100% correct. For example, for price, you can say, okay, you guessed correctly that it's a price, but your estimation
yeah.
of what it can do is off.
Yeah, exactly. So everything is configurable here.
Yeah,
So
yeah.
we have the YAML DSL, and you can write a lot of
Yay, more
configurations for
YAML.
everything. Yeah, more
Exciting,
YAML. Yeah,
exciting,
exactly.
more YAML.
More
All
YAML.
right, and this goes into the theme of the Build Propulsion Lab, which is developer productivity, and it's basically what we can do is write better tests.
Yeah, exactly.
And how do we do it? How do we approach it? How do we improve our development cycle with tools such as these?
Yeah, exactly. That's what my talk tomorrow is going to be about. My talk is called mocks versus test containers, and yeah, it's maybe a catchy name because like you might think there's going to be a fight, and someone's going to win this fight. But yeah, I have to say that in the end we will figure out that you need both, actually, both approaches, mocks and test containers.
Okay, I would say that why do you need mocks if you have test containers? So you can replace
Yes.
everything that you mock with a proper test container implementation.
Yeah, that's exactly the point that I'm going to oppose in my talk. Yeah, first of all, I have to say that I'm a huge fan of test containers. I've been using this library since like 2016 when it appears. I contributed to this open source library. But on the other hand, I'm not affiliated with Atomic Jar or Docker, so I have some unbiased view here. And really, you face some problems that you cannot overcome with your real system running in a container. For example, take Redis. So Redis running in a container is a real Redis server. But imagine you want to verify the behavior of your application in case Redis fails. How do you make Redis fail and then maybe restart and revert in a test container? Because Redis normally doesn't fail, right?
I would imagine that something like that should be part of test container functionality, and I have to admit I know enough. But I would say that this sounds like a very cool feature for test containers itself, to be able to emulate the failures
of
the containers that they provide.
Yeah, failure is it's a generic problem, right? So we can move it to test containers, although it's not there still. But
Sergey, Oleg, Eli, you have some work to do. Go for it.
Yeah, surely, and we can contribute. Yes, as always, as open source community. There are some other more specific things in specific libraries. Like if we are going to test Kafka applications, it's a very the problem here is that Kafka is a asynchronous system. And when you're going to test asynchronous systems, you have to wait for reply. So there are waits, there are timeouts, and stuff like this. If you are using some specific mocks, then it turns your asynchronous testing into synchronous one. So you have specific API designed specifically for testing in order to get the full reply from your Kafka cluster and validate that it's correct reply. And you cannot achieve this using a real Kafka cluster. So these are
sometimes having something which is not real actually represents your environment better than something that is real but simplified.
Exactly. So there are some problems that cannot be solved with in testing, that cannot be solved with real systems and containers. And you need to understand the limitations. On the other hand, like immediately, I can give you very simple examples of things that will give you green tests in mocks, and will behave like absolutely different.
This is your classic use case for test containers. I wanted to ask you something, and I think you are the perfect person to ask about the whole hey, test containers actually represents your production systems, because it's not. And the difference is not only what you described, that it's simplification, so it might not be representative, but I would say data is the biggest differentiator, right? The amount of data that you have in production
Mhm.
is not something you can or want to replicate for your tests, because it will just be too expensive and basically too large to run, but it can affect how the system behaves.
Yes, exactly. That's another use case for mocks, by the way. So if you want to test something in Redis, some geo hashing, for example, it might be difficult to set up data for this in Redis, and it takes time. And it takes time to spin up the container. While in mock, you just say, on this request, give me this reply, which is needed for my test scenario, and it runs like this. And this makes developers to write more tests and run them more often. That's what we need for developer productivity.
Absolutely, we want more feedback, um,
Faster feedback.
faster feedback, and that's more faster feedback. That's exactly the essence of developer productivity. So I wonder if there is a scenario in which the you just give up and you say, you know what, our production environment have so much data, then whatever we try to do, either mocks or test containers, none of them can realistically represent our production environment. Not just because the sheer amount of data that we have and the side effects that this amount of data generates. And then you can say, you know what, it's impossible. We will do the next big thing, the next thing, the next closer thing, but it's not. We know that it's not representative of production.
Uh, well, you're painting a picture for me, and I'm as engineer starting to think like
Exactly.
how to solve it.
Yeah.
And the answer is, as always, it depends. It depends like the nature of problems. So if there are some performance problems, then we can isolate these performance problems and maybe mock some latency and try to solve
Like
it like this. Timeouts. If it's I don't know, if it's bugs in database itself, then it's another story. So we need to test this. So actually, yeah, when we come to this to problems that difficult, well, we need to decompose, and there is no one size fits all solution.
That makes sense. I probably thought about more like latency, that it takes just longer time to get a response, which obviously this containers won't help because it's an empty. It's an empty image or almost empty, so the responses will be very fast.
By the way, we have a plugin in Synthesized, a free plugin. By the way, you can download it from Maven Central, which works with test containers. And while test containers usually give you like an empty database, given our plugin, we can provide you with not empty database. You give us a schema, and we give you a database with some data in it, just enough, not much, but just enough to write some business logic tests.
Yeah, perfect. Okay, so that's one thing. But again, it won't be my entire production database.
Yes.
And then if I want to mimic the behavior of my production database, then maybe test containers should also have some, as we just spoke about, the ability to test failure of behavior.
Yes.
Maybe test slow,
latency,
slow down and latency problem behaviors as well.
Breakdowns as well. Yeah. So actually, yeah, there are in integration testing, there are many very difficult scenarios.
Yes, exactly.
And maybe unsolved problems. And especially when it comes to asynchronous systems and distributed systems. I'm going to talk about it a bit at my talk. And actually, both test containers and mocks are our friends. But, well, our biggest friend is our own head and our understanding of
the business
and limitations of the business needs and of the limitations of the technologies that we are using. So only this can lead to solution of the problem.
This is great. So with that, use your own head. I think that can be a highlight of any interview that we do, but especially here. Tune in to Ivan's talk later today if you are here at Devoxx UK. If not, if you're not, they're all recorded. They will all be published. So do not miss that. Ivan, thank you very much.
Thank you.
That was excellent.